Okay, so we're looking at the second year Stats and Mechanics textbook, and we're doing question 4 from exercise 8E, and the focus of this exercise is integrating vectors, although there is certainly some differentiating in amongst the questions as well. Okay, so what have I got? I've got the acceleration as a vector, and I'm given the initial velocity. So in t is 0, I've got the velocity. Okay, and the first thing they ask me about is the velocity. So what we need to know, because they don't actually tell you this in the question, is that velocity is going to be the integral of acceleration. So I'm going to integrate acceleration. Okay. Right, so when I integrate that, and I'm going to do this one slightly differently to how I've done some of the earlier ones, because there's two slightly different ways of laying this out, and you can pick the way that makes most sense to you. So what I've done for the previous questions is I've just done the constant on its own at the end. But what I'm going to try for this one, just to show you the alternative, is do the constant for the I vector and the j vector separately. And you can then decide which way makes most sense if you're finding this a bit tricky. So I'm going to integrate the 5t minus 3. So that's going to become 5t squared over 2 minus 3t. Then I'm going to put just the constant of integration there, okay? And then I'm going to integrate the 8 minus t. So that's going to integrate to 8t minus t squared over 2. And then I'm separately going to put the j constant of integration there. And they're not going to be the same thing. So you could call them c and d. I call them c1 and c2. Okay, so this is just alternative to how they've done it in the textbook, which is they just put the constant of integration as a separate vector. Okay, but just in case this makes a little bit more sense. So then they tell me that when t is 2, the velocity is, when t is 0, the velocity is 2i minus 5j. So, and I could even just look at the I and j vectors completely separately. So there's my I vector. So when t is 0, the I velocity should equal 2i. And if I sub 0 into this, I just end up with that c, because that, oh, let me do that, sorry. Let's do a different color highlighter. So because that will be 0 and that will be 0. Okay, so the constant c1 is 2. And then if I do the same thing for the j component, okay, so the velocity at t is 0 and the j direction is minus 5, which you don't miss that minus. And if I sub 0 into, again, right, if I sub 0 into this, I get c2j, so c2 must equal minus 5. And you might even, if you're sort of feeling okay about this and you're just using this video as a check, you might just have realised that as soon as they told you that was the initial velocity, and that's absolutely fine. Okay, as long as we end up with velocity is 5t squared over 2 minus 3t and then plus 2, my I vector, and I'm just going to run out of room there, so let's squeeze that on. And then for my j vector, it's 8t minus t squared over 2, and then minus 5. Okay, so it's just a slightly alternative way of laying it out to how I've done the previous few questions. Okay, and that's what they wanted for part A, so the velocity of p after t seconds, so that's just a general equation there. They haven't given me a specific value of t to evaluate. Okay, so then the value of t for which p is moving parallel to the vector I minus j. Right, okay. So this is why this one's a problem-solving question. So we're going to have to think about what's going on there. Okay, so there's your I vector and there's your j vector. So if it's moving parallel to I minus j, that's going to be I. Let's go this, so nice and straight there. So that's I, and that's minus j, and we want to know when it's moving in that direction. So that is going to be kind of anywhere along that line. And you don't need to use angles here, but that would basically be a 45-degree angle. So that's what they're saying. If we're talking about when something is moving parallel, so the direction it's moving in, that's going to be to do with its velocity, which you probably guessed because that's what we just worked out. So when is it moving in that direction? Well, that's going to be when its I component equals the negative of its j component. So when does 5t squared over 2 minus 3t plus 2 equal the negative of 8t minus t squared over 2 minus 5. Okay, so that's what they're saying. When is it moving parallel to I minus j? So when is it moving in that direction? Okay, and if that's a 45-degree angle, so if you think, imagine a 45-degree isosceles triangle we've got there. So anywhere on this line here, or you could even think about it sort of just in terms of, an x and y coordinate axes, anything on that line there, so that would be the line of y equals minus x, or x equals minus 1. Okay, so now we do specifically want it to be moving that way. So it's the worst arrow in the world ever. Let's try that again. So I do specifically want it to be moving that way. That's not much better, and not that way. But we'll come back to that at the end. Okay, so I basically got that quadratic to solve. Okay, so I just want to be careful about how I tidy it up. So I am going to multiply through by 2, but I'm going to really break this down so I don't make any slips. So first thing I'm going to do is lose those brackets, so everything is going to get multiplied through by minus, by that negative. Then I'm going to multiply, actually I don't think I do need to multiply through by 2, because if I subtract the half t squared from the 5 over 2t squared, that's just going to be 2t squared. And then minus 3t plus 8t and 2 minus 5, and I'm pretty sure that factorizes. So if I go 4, a 3 and a 1, and I make that plus 6t minus 1t. So t is a half, or t is minus 3, except t is time, so it can't be minus 3. And if I go back to the question, they just wanted a value for t. Right. So now one thing I haven't actually shown is whether it's traveling, let's do this, right. So whether it's traveling that way or that way. And I want it traveling down to the right, okay? Now, because I've only got one solution, I'd be pretty happy to assume that that's got to be the correct one. If I did want to just triple check, if I substitute t as a half back into my velocity vector, that should be positive, so it's traveling in the I direction, and that should be negative, so it's traveling in the negative j direction, okay? This question is already long enough, this video is already too long, so I'm not going to double check that now, but that's what I could check just to clarify it is moving the way it should be. Okay, so then find that, well actually, to be fair, I'm now going to calculate this to answer part C anyway, so I can check it then. So then they want the speed of p, so that's fine. So let's just check our answer. Oh yeah, t is a half. Okay, so as I say, assuming we've got the correct value for t, we now just need to substitute that into velocity. So let's drop down the velocity vector again. So it was 5t squared over 2 minus 3t, just see it there, plus 2i plus 8t minus t squared over 2 minus 5j. And now I'm checking what that equals when t is a half. And if I'd got part B wrong, these would be follow-through marks, hopefully anyway. Okay, so let's sub a half into that. So a half squared times 5 divided by 2 minus 3 times a half plus 2 is 9 over 8i. Now, and this will be a good check as well whether we've done this correctly, because for our answer for b to be correct, if that equals 9 over 8, this should equal minus 9 over 8. If I was feeling really cocky, I could just assume that it does, but I'm not, so I'm going to double check it. So now I'm just subbing a half into my j vector, so 8 times the half minus the half squared over 2, minus 5, awesome, does give me, does give me minus 9 over 8j. Okay, so that's also just to check that my answer to part B does seem to be correct. And then always, always, always read the question really carefully. It doesn't want velocity for my final answer, it wants speed. So 9 over 8 all squared. I'm squaring, so I'm not really bothered about the minus. I can put it there if I want to, but it's not going to change my answer. Okay, so 9 over 8, 9 over 8 all squared, plus another 9 over 8 all squared, square rooted, is giving me 3 root 2 over 8. And it doesn't ask for exact form, so I could leave it like that, or I could put it as a decimal. Let's just double check. No, I've done something wrong there, so hopefully we can spot that. Really don't want to have to do the whole video again. Okay, let's try that again. So 9 over 8 all squared times 2, root answer. Yep, so just something wrong with how I typed it into my calculator, so always worth double checking. But that should have given me 9 root 2 over 8. Okay, so that method is fine. It's just calculator error. Let's double check that one more time. 9 root 2 over 8, we're good.